So today, what we're looking at is we're going to talk about inverse norm and normal probability plot. We did a warm-up earlier that talked about how to do the inverse norm with our calculator. We'll go over that again today. So the question today, or the story behind it, is the heights of 3-year-old females are approximately normal with a normal distribution, with a mean of 94.5 centimeters and a standard deviation of 4 centimeters. What is the third quartile of this distribution? So if we draw a picture again, like we did earlier, and then this time, Garen, they actually tell us what the mean is and everything like that. So it would look something like this. Because the data this time is not 0 and 1. So this time we're actually using that, okay? So then we could come into here and put this as our mean. And then 75%, I'm just going to approximate it's right here. Because it's our third quartile, right? And so what this shaded means is that 0.75 is covered up. And what was that? Yep. Because what we're looking at, what we would have done before is we would have used our normal CDF. We would have put in this value right here, which is unknown. That would, our lower bound, it would have looked like this. We would have had a lower at -1E99. Our upper would have been that X value. Our mean would have been 94.5, and then our standard deviation would have been 4. And then that would have given us 0.75. Okay. But we could switch around and say the upper quartile, you know, so 0.25, we could have changed it like that. So we're going to go inverse norm, and then it's going to ask for our area, which is 0.75, our mean, which is 94.5, and our standard deviation is 4. So the inverse norm, second distribution, pulls that up, and then we can see that it's right there. So we hit number 3, and then we're going to hit 0.75. Our mean is 94.5, 94.5. Standard deviation is 4, and it's a left tail test if you're using these calculators. If not, we'll have to come up with another video to show you how to fix that. So we're going to hit paste, and we find out that the value is 97. Let's just go 97.2 centimeters, because it's got that 1.979. Everything's going to be rounding it up. Okay. So what does this mean? So we would say the third quartile of our data set is 97.2 centimeters. So you technically could plot how to do your box plot this way as well. So any questions of that? Okay, so the AP people will be looking for this statement here. Okay, they don't want to just see this, they want you to actually translate it into a statement there. Okay. Okay. So what we've been talking about is we're trying to assess how something can be normal. Okay. And so to do that, we're going to use a normal probability plot. And so we're going to type in all this data set into list 1. Okay. It's all going to be in one list. And then I'll show you what to do after that. So we've got our data set plot in. So we're going to go to second stat plot. And then we're going to come here and we're going to choose this last one out here after the box plots. So we're going to come out here, hit enter. Now what this is going to do is it's going to put our data set and the expectation of what we're seeing with them, okay? So what we do is we got everything right here. You want your data axes to be X, and then what we're gonna do is we're just gonna hit graph after you got all your color and everything else picked out that you like, okay? Now, mine's still thinking. I can see that it's thinking because it's got that yellow circle up here, so I'm not gonna do anything until it's done thinking. Uh-oh. Oh, somebody was kind enough to put a whole bunch of crap in there, so I gotta clear this. So now I can see if it's gonna graph. Now it's not showing up, so I'm gonna hit zoom. Zoom stat number 9. Woo! Oh, look how pretty that is. Anybody not get that? I'll pause the video and fix it. Okay, so nice and linear, correct? Pretty linear. So if our data points are linear, or you could even say approximately linear, then we can proceed to do a normal distribution test. That's just our z-scores. Okay. Question now is the y. I can't remember. I'll have to come back to you. Give me 2 seconds because I got this next part in my head. Give me a second. All right. So what does it look like? If it is not normal. So we're going to do an activity. Okay. So what we're going to do is we're going to go to probability. So this is found underneath the math button. So math. Oops, you can't see it. Go to math. Move over to probability. Everybody there with me? Okay. We're going to select number 6, the rand norm. Okay. So select. So I get that, right? Okay. So we're going to take random normal. It's going to be 0, 1, 20. So we're selecting numbers between 0 and 1. All right. Oops. So it looks something like that on my calculator. Close. Yep. Close your parenthesis. Good. Now don't hit enter yet. Don't hit enter yet because I know some of you are excited. I want you to hit the store button. Okay. We're going to store our data into our list 1. So then we're going to hit second L1. Okay. So store into list 1. So it looks like that. And then hit enter. And you should get a bunch of numbers, right? With me? Okay, so I'm going to pause it just for a second. Okay, so we put our list in. If you want to check out your list, you just hit your stat and you can edit it and you can come see that your data has been entered into it. Okay, so if you go back to your stat plot and plot that data set, we're still using list 1. I got to answer Nathan's question still. I hit graph. I'm going to hit zoom 9 so it fits. Now, It changed because our data set changed, right? So what do you notice about my data set? It's different than yours, but what else? It's still pretty linear, but I got a whole bunch of curves in there. It's almost like a power of 3 function. I might be a little bit concerned about it. Okay. How about your guys? Scott, what'd you get? It's up to you, Scott. So what we can do is we can go back to our data set, right? So if I just quit and come back to here, and I hit enter, it's going to give me a different list, right? And I can plot that one. Oh, what do you guys think about that one? Not linear, not really. So what I want to use my normal distribution? I wouldn't want to use my z-scores. Okay, so if I do it again, real weird, right? So how about that one? I don't like this point right here, and I don't like that curve. So if you're stuck, you can always take like a piece of paper and you can come up here and say, well, how can I make my best line a fit? And I just don't like that data set. I don't think it would be normal, okay? For it to be really normal, it's got to go back to this guy right here where we had that nice straight line, okay? If it's not linear, don't risk it, okay? Okay.